Hello, everyone. Today, Stéphane and I are going to give you an update on Sirius Web and share what has been happening recently in the project. I'm Mélanie CTO at Obeo, and with me is Stéphane Bégaudeau with the architect behind Sirius Web.
Hi everyone, I'm working on the architecture and the implementation of Sirius Web, and today I'll walk you through many of the improvements that have happened recently on the project.
So let's start with the bigger picture with a quick reminder of what Sirius is. Sirius is a Next Foundation open source project dedicated to building domain-specific graphical modeling tools. It has been around for more than 15 years now, and it has proved itself in complex engineering environments. The core idea is very simple. Sirius lets tool builders focus on their domain concepts and rules instead of spending time building low-level graphical infrastructure. In other words, you bring your model and your rules, and Sirius helps provide the graphical workbench around it. And this naturally led us to the next step, bringing this approach to the web. With Sirius Web, the goal is to make modeling tools easier to access, easier to deploy, and easier to integrate into modern environments. For end users, this means no local installation and no complex setup. Everything is accessible directly through the browser. And technically, this also makes integration much easier with today's ecosystems, whether we talk about ALM, PLM, CI, CD, or authentication services. It also creates a better foundation for scalability and for more collaborative usage patterns.
To understand how Sirius Web supports all of this, let's look briefly at its architecture. So Sirius Web relies on a Java and Spring Boot backend with a React-based frontend. The platform uses a declarative approach with a Vue DSL, so tools builders don't have to code every part of the user interface manually. It also remains compatible with EMF data structure, which is important for the broader Eclipse modeling ecosystem. And from a product perspective, this open foundation is also key. It gives transparency, extensibility, and a solid base for industrial adoption.
With that in mind, let's look at what has changed recently, because a lot has happened since late 2024. Sirius Web has been evolving very quickly over past months. The project is very active with a strong contributor base, frequent pre-releases or one release each 8 weeks, and a steady flow of improvements across the platform. This strong rhythm reflects the growing adoption of Sirius Web across several modeling tools and use cases.
And this activity has translated into many concrete improvements. So since the end of 2024, Sirius Web has evolved very quickly in various directions. We've introduced continuous improvements in usability, diagram editing, performance, new representations, and also worked on its extensibility.
And we choose to start with end users because many of the recent improvements are immediately visible in day-to-day usage. A lot of that progress comes from work on the workbench itself: navigation, feedback, responsiveness, and overall usability. These changes are not always spectacular on their own, but together they make the platform much smoother and much more comfortable to use. And that matters a lot because adoption is not only about features, it is also about whether the tool feels simple, fluid, and reliable on everyday work.
We improved the action in the project contextual menu used to generate a shareable URL for the current workbench state. This shared state can now include things like the current selection, the views that are opened in the left and right panels. So instead of only sharing a project, users can now share an entire working context, which makes collaboration much easier. And users can now display multiple Workbench views simultaneously on the left and right panels. It gives them more control over how they structure their workspace and access information. It helps create a more modular environment where users can focus on the views that matters for their current task.
Another area where Sirius Web has progressed a lot is diagram editing. This is really central because for many users, the diagram is still the main entry point to interact with the model. Over the last releases, we worked a lot on making diagram editing smoother, more readable, and more comfortable in day-to-day usage. And this is really about maturity, not just adding features, as I said, but making the editor feel more natural and more robust. The goal here was to make diagram editing more fluid and more predictable. That includes better feedback during move and resize operations, more intuitive selection handling, improved tap-to-grip behavior, more consistency across browsers, and also reducing latency in the front end. So the result is quite simple. Editing feels smoother and more reliable. So
a good example of that is the work we did on the palette. The palette is one of the first things users interact with when they create or modify elements in a diagram. So reworking it has a strong impact on usability because it makes action easier to find and easier to trigger. This is why we have added tons of new features here with quick tools, tool sections, search, or even the support for shortcuts. We've also made it easier to create good-looking edges very quickly with auto-connected edges. Start creating an edge and aim at the center of your target. It will create an auto-connected edge, which will try to take the shortest path to its target. You can move your nodes after that, and we will move the edge to take the shortest path. This is a good example of how small interaction improvements can have a strong impact on user comfort and efficiency. But of course, users still need full control when they want something more explicit. With manual connect, you just have to aim at the border of your target, and we will remember where you want the edge to be attached. You can move your node, and we will make sure to keep the edge attached to the same location. Of course, you can switch from manual to auto-connect anytime you want. Once the connection is created, the next step is to give user more control over its final shape. For that, you can move individual edge segments to improve the readability of the diagram without redrawing everything.
beyond editing itself, another important question is understanding the consequences of change. So impact analysis helps users see how modification can affect the rest of the model. In complex systems, changes are rarely isolated, so this kind of feedback is very important to support safer decisions.
We also continue to improve the visual expressiveness of diagrams. Appearance customization gives more control over how model elements are rendered. The end user can thus change the appearance of the diagram elements very quickly. We will remember this customization, and you can easily restore the default appearance of each property. So here we've changed the background, but we can also change, for example, the label and put them in bold very quickly. The same logic applies to links between elements. With edge appearance customization, we can support richer visual conventions for relationships. You can even change the layout style of the edge. So here we can go from Manhattan to Smart Manhattan to just a simple straight edge. As the diagram becomes richer, managing the complexity becomes important. Managing visibility is key when diagrams grow in size and density. Users need to focus on what matters at a given moment without losing the overall structure of the model. So the goal here is to really help users control the complexity of a diagram instead of being overwhelmed when everything is visible at once. Label management may sound secondary, but in practice, it has a huge impact on the readability of the diagram. If labels overlaps, move unexpectedly, or becomes hard to edit, the whole diagram quickly becomes frustrating. You can now move or hide labels very easily. Of course, you can restore everything just as quickly. Once labels are better managed, it also makes sense to give user more control over them. Labels are now resizable to let user adapt the display of textual information to the situation. This is especially useful for long names, annotation, or use cases where readability matters more than compactness. We have updated how the selection works in the Workbench, and users have now more control on its behavior. Previously, anytime you selected something, we tried to show it at the same time in every Workbench view and representation. You could essentially work only on a single element at a time. Now, each Workbench view and representation can have its own selection. You can select something in the diagram while viewing something else in the Explorer, while also editing the properties of another element in the details view on the right. You can, of course, reveal your selection in overviews very quickly to find what you need. This improvement has a strong impact on the overall editing experience.
So all these richer interactions will not be useful without strong performance improvements underneath. One major step forward was the update of the Sirius EMF JSON format. It made loading and saving semantic models dramatically faster. For example, a model with 200,000 semantic elements that used to take around 40 seconds to open can now load in just over half a second. Even very large models with more than 1 million elements can now be opened in only a second or so, few seconds. And since saving happens continuously during editing, this also makes the whole experience much smoother and much more responsive.
We've added filtering directly in the Explorer view. This capability already existed through keyboard shortcuts, but it is now much easier to access thanks to a dedicated button in the toolbar. So end users can activate filtering more naturally and quickly limit the visible content to what really matters to them.
Beyond speed, another very important topic is diagram readability. Readability is a primary concern in modeling because a diagram is not only something you edit, it is also something you review, discuss, and share. Recent updates have improved link routing with smarter algorithms for Manhattan and oblique paths, as Stéphane just saw, better layout stability, and a clearer handling of labels and intersection. The result is that diagrams stay more legible and more professional looking without requiring constant manual adjustment from users.
A good example of that is how we now handle edge crossings. Here, the goal is to make intersections easier to read when many links crosses each other. This may look like visual details, but in dense diagrams, it makes a real difference in readability. Another important improvement was the support for more advanced type of relationships. Edge-to-edge connections are useful for notations where a relationship can target another relationship. This gives more expressive power to the editor and support more advanced graphical semantics. We also wanted to give users more control over the layout of edges. Editing the path of edges gives users a final level of control over the final layout. This helps preserve readability in dense diagram without forcing users to fight against an automatic routing. So once again, the idea is to combine smart defaults with explicit user control.
Another way to improve readability is simply to make better use of screen space. That is the idea behind the compact layers, for example. It reduces unnecessary white space in diagrams, so users can see more information at once without losing clarity. This is particularly useful in real projects where diagrams often need to stay readable while covering a large amount of content. Once a tool becomes more mature for editing, the next challenge was for us scaling reuse across projects. As models grow in size, modularity becomes essential. With libraries, Sirius Web now makes it possible to define common components or shared assets in one place and then reuse them across several projects. This avoids duplication, supports better governance, and helps organizations build a more consistent and scalable modeling environment.
So let's look at what this means more concretely. With libraries, tool builders and end users can reference shared content instead of duplicating it. This helps maintain consistency, preserve data integrity, and create a stronger single source of truth across projects. Another benefit is that reuse does not mean losing control. You can create a library from a project, publish it, inspect it, and finally import it in another project.
So once reuse is in place, another major topic is everyday productivity. To support daily use, we introduced several improvements focused on helping users work faster and with less friction. This includes global search through the Omnibox or dedicated search view, bulk actions on multiple elements, faster navigation between representations, and more direct access also to common operations. Each of these changes may look small on its own again, but together they save a lot of time, especially in large and complex projects.
A first example is the search inside of the project itself. So the search view gives users a dedicated place to find elements, diagrams, or other artifacts quickly inside of the project. And from a user perspective, this changes the experience quite a lot because it turns navigation into a much more direct and intentional action. We've also improved quick access to commands and elements through the command palette. So the command palette is a very efficient way to navigate and trigger actions quickly. Users can open it with a shortcut, search for any element by name, even if it's hidden, and access it immediately. And once search works well inside of one project, the next logical step is to extend it cross-project. Cross-project search extends this capability beyond a single project. So instead of thinking in isolated workspaces, users can locate information across a broader working environment. Another new workflow is duplicating existing content. We've added the ability to duplicate semantic elements and representation directly from the Explorer. This includes options to duplicate contained elements, preserve outgoing references, or even update incoming references, which make it much easier to replicate complex structure easily and safely. We've also improved the selection workflow in dialogues. Using a tree inside the selection dialogues make it much easier to browse and choose the right element in a structured way. It can also be used to select multiple elements at once, as you can see it on screen.
So far, we've mostly looked at improvements for end users. So let's now switch to studio makers. I mean, people building modeling tools. And on that side as well, a lot has happened recently to make the platform more flexible, more expressive, and so easier to adapt to specific needs. One of the major steps forward in Sirius Web is the addition of new ways to explore and edit models. This is important because diagrams are powerful, but they are not always the best answer for every task. So we introduced new representations that complement diagrams. One of the first major additions on the Studio Maker side is the tree representation. Diagrams remain very powerful, but they are not the most efficient way to explore deeply structured models or large volumes of elements. The tree representation provides a dedicated hierarchical view of model elements, and this is important. It is not just a project explorer, it is a real representation, a real serious representation, which means users can interact directly with the model from there, rename elements, create new ones, or reorganize content. It could also stay synchronized with selection, so users can move also naturally between different views, and that's really, really useful.
So let's look more concretely at what this tree representation brings. From a technical point of view, this is a real Sirius Web representation, not an auxiliary navigation widget. This means it can be configured with the same modeling logic and integrated naturally into the Workbench. It gives users an efficient way to browse and edit the model structure directly, especially when hierarchy matters more than layout.
And for some use cases, even a tree is not the most natural representation. That is why Sirius Web also introduced table representations. For many engineering tasks, a grid-based view is simply more useful than a graphical one, especially when users need to inspect or compare structured data. This makes the platform support both visual and data-centric ways of working with the model.
On the implementation side, tables already come with a rich set of capabilities. They already support a rich set of interactions, such as column filtering, hiding column, resizing rows and column, exporting content to CSV. They can also be extended with custom widgets. And this is important because it makes tables not just a passive view, but a real working environment for users who need to inspect and manipulate structured data efficiently.
In addition to these new representations, we continue to improve the overall flexibility of the platform for the studio makers. The objective is to make Sirius Web more adaptable so tool builders can shape representations more closely around their user needs.
We've also introduced a new way for users to inspect and explore their model more directly. The query view allows end users to write SQL queries directly inside of Sirius Web and evaluate them in context. This is useful for exploration, validation, debugging, advanced model analysis too, because end users can rely on variables such as the current selection or the current element. And you can also export the result in CSV too. You can now update the behavior of your representation without leaving your web browser. In a single click, you can fork the description of your representation to change its behavior. So here, let's make the capture subsystem with a blue background instead of the gray one that we can see right now. Clicking on the button will create a studio in which you can change the behavior and appearance of anything inside of the diagram. You can change anything. So here we can customize the background color of the system node, And if we go back to our existing diagram, we can see the result dynamically. In a couple clicks, we change anything.
So far, we have looked at end users, studio makers, but for developers as well, Sirius Web has evolved a lot. The focus here is to make the platform easier to extend, easier to integrate, and easier to adapt to specific technical and organizational contexts.
One concrete aspect of that flexibility is internationalization. It is important because many Sirius Web-based tools are used in a multi-language environment. Supporting that properly means making the Workbench easier to adapt in different contexts and also easier to integrate in products that need to address a wider audience. So here you can see Sirius Web in French, for example. Another important step was giving developers more control over what is visible and available in the interface. Capabilities provide fine-grained user interface control, which means the Workbench can now be configured more precisely depending on the use case. Here, we have a demo version of Sirius Web, initialized with some data, and after that, we have disabled all the editing capabilities. So, for example, you can't create projects anymore. You could not delete existing one. You can't update data. You can't update representation. You can just have a read-only version of Sirius Web.
And this broader trend continues with more advanced customization options for tool builders. Sirius Web now offers more flexibility on several dimensions: style customization, dynamic UI behavior, project-specific views, and easier branding integration even. This means that teams can go much further in aligning the Workbench with their own domain or their own corporate identity. So the platform is not only more powerful technically, it is also more adaptable as a product foundation.
Another key topic for developers is integration. Sirius Web now provides an improved GraphQL endpoints, REST API, and new front-end extension points to add custom React components or widgets to existing representation. There's also an official Docker image now. So overall, the platform is becoming easier to connect to, easier to extend, and easier to deploy.
And finally, all of this also has to work at scale. Beyond individual features, Sirius Web has continued to progress as a platform that can support larger models, larger teams, and more demanding usage conditions. Several improvements were introduced to make Sirius Web more robust and more responsive in large environments. On the front-end side, virtualization means the UI only renders what is actually visible, which keeps interactions fluid even with thousands of elements, especially in query and search views. Large explorers and lists also use progressive loading, so only the relevant subset of data is fetched at a given time. And on the backend side, memory management and request handling were optimized also, while deployment was made easier with the official Docker images and improved so Kubernetes-oriented configuration.
A good example of productivity at scale is the introduction of batch tools. Batch tools make it possible to apply the same action to several selected elements at once. This is very useful when users need to perform repetitive modification across a large part of the model. Here you can hide multiple elements at once. You could customize the appearance of multiple elements at once too.
So at this point, we've seen a lot of progress inside the platform itself. Let's now step back and look at the bigger picture. Sirius Web is not evolving in isolation. What makes it especially interesting is the ecosystem growing around it, and the way improvements in the core platform benefit a broader family of tools and use cases. This is where Sirius Web and Obeo Enterprise for Sirius really come together. Sirius Web provides the open source core building blocks. Obeo Enterprise for Sirius builds on top of that foundation with enterprise-grade capabilities such as advanced security, scalability, and dedicated support. And together, they support a wider ecosystem of solutions, including tools like CSON, Papyrus Web, Smart EA, and also the latest version of the ESA's ground and space segment engineering framework. So the same core platform can power both open innovation and industrial production. A good way to see that ecosystem in practice is to look at the variety of tools already built with Sirius Web. The Sirius Web Gallery illustrates the diversity of use cases supported by the platform. It shows that Sirius Web is not tied to a single domain, a single notation, or a single product shape. Instead, it acts as a common foundation that can be reused to build very different kinds of modeling tools. And this brings us naturally to Obeo Enterprise for Sirius. Obeo Enterprise extends Sirius Web with capabilities that are especially important in enterprise context. The idea is not to replace Sirius Web, but to come with additional features that are operational, organizational. So Obeo Enterprise for Sirius is really the enterprise layer that helps teams move from open source platform to production-ready environments.
To understand that better, let's look briefly at the Obeo Enterprise for Sirius architecture. Obeo Enterprise for Sirius builds on top of Sirius Web and adds enterprise-oriented services around it. The goal is to keep the openness and extensibility of the core platform while providing additional layers for governance, security, collaboration, and deployment. From a technical point of view, it's really an extension of the Sirius Web Foundation rather than a disconnected product. And from that architectural base, Obeo Enterprise for Sirius introduced a set of features aimed at enterprise usage. First of all, authentication support with OAuth2 or username password, webhook integration, and visual collaboration to prepare the platform for more advanced capabilities in the future. So here, for example, in the details view, you can see your colleagues, other users, clicking on the various widgets. So you can see what other people are doing on your models.
A first key capability in Obeo Enterprise for Sirius is also the way it structures access and collaboration. Organizations provide a shared workspace to structure teams and control access to projects in a way that is quite similar to the GitHub organizations. They give a clear perimeter for grouping related projects under a common ownership model, and they make collaboration easier to scale while keeping responsibilities really clear. So instead of managing access user by user in an ad hoc way, Obeo Enterprise for Sirius provides a much more structured and sustainable model. And of course, we are not stopping here. Looking ahead, there are three major directions we're exploring for next year. The first is advanced collaboration with real-time multi-user editing, visual presence such as multi-cursor support and version management also. The second is assisted modeling, especially through AI-powered support for model generation, refinement, and consistency checking, for example. And the third is still the UX continuity, continuing to bridge the gap between the power users expect from desktop tools and the simplicity they expect also from web applications.
As the platform grows, the documentation becomes more and more important. Good documentation is essential for both users and developers. It helps people discover features, understand how to use them, and adopt the platform more efficiently. The Sirius Web documentation will be available during the next iteration.
Another important feature in Obeo Enterprise for Sirius will be support for discussion directly in the workspace. Comments make it possible to attach feedback and discussions directly to the relevant project context and specific semantic element. This will help teams centralize exchanges, preserve the rationale behind decisions, and avoid spreading important discussion across too many external tools. Another direction we're exploring in Obeo Enterprise for Sirius is AI integration. AI can help users create, refine, and complete model elements more efficiently. It can also accelerate repetitive tasks such as documentation and provide more relevant guidance by using the project and model context. So here again, the objective is not to replace modeling, but to make the platform more helpful and more productive for users.
And so from a technical perspective, this can open several interesting directions. One possible direction is to rely on MCP server integration to connect AI assistant to external tools, services, and project data in a standardized way. Another is to introduce custom skills tailored to specific domains or project tasks, so the assistants can provide more relevant or more contextual support. So the long-term perspective is not just generic UI, but domain-aware assistants that fit naturally into the Sirius and Obeo Enterprise for Sirius environment. So here we can ask questions to an LLM, which can understand what is going on inside of our project, but it can also interact with our project. We can ask it to create semantic elements, to add them to an existing diagram, and it will tell us everything it did and how it made these decisions.
So we really value your feedback because it helps shape the future of Sirius. Our roadmap is adaptive, which means we continuously adjust our priorities based on what matters most for users and adopters. And in the coming months, both Sirius Web and Obeo Enterprise for Sirius will continue to evolve according to the needs and interests we see from the community, from the real projects. So if you have ideas, expectations, or concrete needs, this is the right time to share them. We also welcome contributions from the community as well as sponsorship opportunities, because this input is essential to help the Sirius project grow in the right direction. To conclude, Sirius Web has reached a new level of maturity. It is now a true multi-representation platform with diagrams, trees, and tables, and it is much better prepared to support enterprise scale models and demanding usage scenarios. And with Obeo Enterprise for Sirius on top of it, there is now a clear path from open source innovation to industrial production.
And with that, we've reached the end of the presentation. Thank you very much for your attention, and we will be very happy to take your questions.
How many people can a workspace be shared with at a time?
There's no hard-coded limit, so it depends mostly on the performance of the machine on which the Sirius Web instance is deployed, and the complexity of the behavior of your diagram. So if you have a ton of data and your diagram needs to display everything, it will require a more performant server, but there's no hard-coded limit.
Okay. Is sharing a workspace part of Sirius Web or Obeo Enterprise? So by default, you can share a workspace with Sirius Web. What's in Sirius Web is that you have no authentication. What's part of the Obeo Enterprise for Sirius is authentication. So if you want to know who is doing what, you need to Obeo Enterprise for Sirius. But by default, Sirius Web is a collaborative platform also, but everyone is at the same level. So you don't know everyone is anonymous.
And with Obeo Enterprise for Sirius, you can also share the workspace while disabling some features. So you can share the workspace with edition capabilities limited to a specific set of users, but you could also share it as a read-only project for another specific set of users or for everyone else. So you have the ability to control the permissions too.
So thanks again, and have a nice day, everyone.